Hello everyone, my name is Resham Singh. This is my credit risk prediction model. This is an AI-based credit risk prediction model which is built using machine learning algorithms and Streamlit. Several Python libraries like NumPy, Pandas, etc. have been used for constructing this particular model. This particular model uses classification algorithms to predict if a loan is likely to be passed by a bank or not. And the Streamlit, which is another library, is used to create a user interface so that a client can enter his or her details and the model will predict if the loan will get passed or not. The model predicts the output with an accuracy of over 70% and by analyzing the past records of over 40,000 clients. This model has been created with the help of my mentor at Pregrad. Now I will take you through the files that have been made to construct this model. Now the first file is an IPy notebook file. In this file I performed EDA, which is as exploratory data analysis, and I also built the model in this file only. First we import the required libraries. Here I have imported NumPy, Pandas, Matplotlib, Seaborn, and many SQL and classifiers. I have also imported these three which will be used for checking the accuracy of this model. Then I have imported Smoth, which will be used for upsampling. I will explain later on. Now I have imported joblib, which will be used for dumping the model to .dat or .pkl file, which are binary files, and I will use this file using joblib. Again, to make the Streamlit app, here I imported warnings to ignore any warning that may come up. Now starting with exploratory data analysis, we first load the data set. After that I have cleaned the data for null and duplicate values. After handling the data for null and duplicate values, I have checked for any outliers using his plots. Here you can see four of the features where his plots were used to detect the outliers, and I have used interquartile range and deleting the outliers. After deleting the outliers, I have checked for any imbalance in the data, and a 9-1 imbalance in the data was obtained. This has been dealt with later on. Next is checking for correlation in the data. So here you can see a heat map, and for checking the correction data, look at the dark red or dark blue features. So these are almost features with almost similar composition. So I have dropped such features. After that I have removed some of the irrelevant or repetitive features like job or working, and some irrelevant features like contact, cellular month, April month, August, etc. I have merged some of the columns which can be grouped into a single field. After that, here is the model building part. First, I have separated the data into dependent and independent data. X represents the independent data and Y represents the dependent variable. So this is the target column. After that, I have divided the data into training and testing part. The testing part is 20% of the data set. Then I have selected this model. So here you can see multiple classification models. But the model that I have selected is extra trees classifier. Here is some information about the extra trees classifier. This is an ensemble learning method that randomly groups the various features and performs decision tree algorithms over them and aggregates their outcomes to get the best possible result. This helps in data sets containing large amount of noise, and that is why this algorithm was chosen. Uh, Coming back to the IPy notebook file, we first make some predictions and then evaluate the model. Here you can see the confusion matrix, and there is almost equal precision recall, which is very less compared to the correct values. That is the number of correct values predicted. Now here you can see the accuracy on the training data, and then you can see the accuracy over the test data. At the end, I have dumped the model into a .pkl file, which is a binary file. The second file is a Python file named loan predictor app .py, which is made using Streamlit so that the client can enter his or her details and get the prediction. Joblib is used for loading the model, which is being stored as a binary file. Pandas is imported and warnings has been imported to ignore any warnings that may come up. So here we can set the page header and the icon and the configuration which is centered. After that we have loaded the model. Next I have categorized the age groups and the job stability, and this is the build features function which will return the features as a dictionary of ones and zeros. Here I have also made a list name order which states in which order these values should be there. As you know, that dictionary does not have any indexing, it only has keys value paired. So after that, here is the header of the website or the app. You can say and the subheader you can, which is the first step, that is personal information. In personal information, the user will enter his age, his marital status, and his education details. In employment section, the user, that is the client, will enter his or her job, and the job stability will be showcased using low, moderate, or high depending on their job. After that, their financial situation will be assessed, like if they already have a loan or not, and how many loans do they have. If they have a no loan, then they don't have any existing risks, and if they have one loan, then there is some moderate financial burden. But if they have more than one loan, then it is a high financial burden, that is likely their loan will not get passed. After that, they have asked if they have been contacted with from bank earlier or not, and how it that go. Then the user has to click on check loan approval. If they have not filled all the columns already, then the statement will be shown. After they have filled, they can click on check loan approval again, and this block will be executed. First of all, we get the features using build features function. So this gives a dictionary, and we use order function, the order list, sorry, to form the data frame in the correct order of the variables. After that, we make the prediction. If prediction is 1, the loan is approved. If it is 0, the loan is denied. And then we get the probabilities of approval and denial, so that the bank manager or whoever is responsible can decide on their own as well. And we calculate the percentage which is showcased here. And then we showcase the key factors that after the decision of the model using if-else statements. Here is a demo of the user interface. So on the terminal, I typed streamlit run loan app.py, and this web page opens up. Loan approval checker. Answer few simple questions, and the AI model will predict whether the loan approval is likely to be approved or denied. Let's say we have a 28-year-old person who is single and has a university degree, and he is probably self-employed, and let's say that they don't have any loans to pay, and the previous contact with the bank went well. So you can see the loan get passed because of the favorable conditions, and you can see why the model predicts the loan to be passed. Now let's say we have a senior citizen, and then let's say he is married and they have basic 9-year education. Yeah, let's say they are retired and they have 2 loans to pay back, and the previous contact with the bank didn't go as well. So here you can see 33% approval chance of the loan basically gets rejected, and here you can see the factors affecting this. So this model is working pretty well. I would like to thank the support staff of Pregrad and the mentors of Pregrad who helped me build this project. Thank you for watching.